So we decided to keep going. It's now 5:07 a.m. I'm going to try and get the 6 through 10 done for 12A and maybe get through problem 15 on the 10, and then I really do have to sleep. I'd like to make a video going over my opinion of how I thought the difficulty was. I'll see if I can get that done too. 6 chairs are arranged around a round table. This is problem 14, 10A. It's 12A, problem 6 from the 2025 AMC 10A. 6 chairs arranged around a round table. Let's go ahead and draw it. We've got a round table. 1, 2, 3, 4, 5, 6. Okay. 2 students and 2 teachers randomly select 4 of the chairs. I'm going to name my students A and B and my teachers X and Y, far from each other. That way we know they're 2 apart. To sit in. Randomly select 4 of the chairs to sit in. What is the probability that the 2 students will sit in 2 adjacent chairs, keyword and, which means you're going to multiply the results, the 2 teachers will also sit in 2 adjacent chairs? I really feel like this is a standard probability question from the Intro to Counting and Probability book. Meaning, and my favorite tactic for a lot of these is what I keep teaching my students, fixed position reasoning. It's very powerful. I can select A to sit in any seat, and now A is the fixed position that everyone else is based on. So now I say, what is the probability that B will sit in either one of these 2 seats? And that probability is 2/5. So then once that's done, I just place B in one of the seats to think about what's going to happen from here. It doesn't matter which one, but there's a 2/5 chance that B sits next to whatever chair, because A does have to sit in one chair. So I call it fixed position reasoning. I'm not sure it's officially called that, but that's what I call it. Okay, so the 2 students and the 2 teachers will. So it was here that when I was solving, I kind of wasn't sure which way I wanted to go about it. I figured I would just say, let's say that the teacher X sits in one of these 2 chairs. So I'm going to say, like, case 1, if X, B, or XA. Essentially, X is by B or A. If that happens, what's the chance that X sits in one of those 2 seats? 2 out of 4. Then I'm going to multiply that by now the chance that Y sits in the seat next to X. That's going to be 1/3. I also want to consider, what if X did not sit next to B and A? And I noticed that that's going to be 2/5 times 2/4. The 2/5 is the same for B's decision. It's like this is case 2 now, where X is going to sit in one of these seats instead. And there's 2 of those seats, but now when Y sits down, there are 2 good seats. Here, out of 3, instead of only 1 out of 3, there's 2 good seats that Y could sit in, so it's going to be 2/3. At this point, you would add these 2, and I'm going to factor out, I'm going to cancel the 2 2's and the 4. So I've got 2 2's and a 4. So I've got 1/15 plus 2/15 equals 3/15 equals 1/5. Now, it was at this point that I really kind of want to find it a different way. And this is why when you're good at probability and counting, you can calculate this answer in a different method and see that the 2 will confirm each other. So I don't have any lack of confidence with fixed position reasoning, but what I did kind of wonder is, what if I had approached the teachers a different way? What if I instead said there's 4 teachers and I want to choose 2 of them, 2 seats, or there's 4 seats, I want to choose 2 of them for the teachers to sit down in. What is that calculation? Well, that's 6, of course. And so out of 6, how many of those seats would have been adjacent without regard to order? These 2, and these 2. And that, of course, is 3 out of 6. If you look back at our work over there, if we had just factored out 2/5 times 2/4, we would have had 1/3, 1/3 plus 2/3. But didn't we have something else? Oh, no. I don't know. I thought I had it another way over here. I thought I had one. Oh, it's probably right here. Okay, yeah, it's this calculation right here because this was the teacher's decision. So 2/4, 1/2 times 1 is going to be 1/2, and this is also 1/2. And so if you take 2/5 times 1/2, you also get 1/5, or here you get 1/2. Same thing, but a different way. This is combinations. How many ways could they choose 2 seats? And then how many of those ways are favorable where they are next to each other like this. So we can be very confident now, 2 different calculation methods. Going to get to the next problem. We're going to keep plugging away. 2025 10A, problem 15. This one took me, I don't know, a little bit longer than I would have liked. I don't know, I think I got it in around 5 minutes, but I felt like I knew what was going on, just it kept making some kind of an error or something in it. But it really isn't that bad. Let's just get started. In the figure below, ABEF is a rectangle. AD is perpendicular to DE, as noted. AF is 7. AB is 1, which means that over here is 1 also, just in case. And AD, this whole side, is 5. Okay, what is the area of triangle ABC? We have to kind of look at this 90 degrees that we know is there, and we have a vertical angle here, and that's your clue about where to start. You got similar triangles by AA similarity. So you're going to write ABC is similar to, and then I need my 90 to be at the same place as my B, which is in the middle, so D will go in the middle. I need C to be the last thing that I write, which means E is the first thing that we write. Once you have an accurate similarity statement, you will never get your proportions wrong. Don't base them off the picture, base them off the similarity statement. You'll make a lot less mistakes. So AB over ED is equal to BC over DC is equal to first and third AC over EC. So I always go first 2 over first 2, second 2 over second 2, first and third over first and third. Now we fill in what we know. We know what AB is. It's 1. We don't know what DE is, so we'll put DE for now. It didn't tell us, right? DE, no, nowhere. Okay. BC, we don't know. DC, we don't know. AC, don't know that either. And we don't know EC. Okay, so I'm going to start labeling some things. I'm going to call AC X. We know what AD is. I wonder if we could also do, no, probably not. I'm going to call this down here Y, and I'm going to call this Z. So let's see, I'm trying to remember how I got this one. I guess we fill these things in too. So we've got names for our stuff now. We're going to have Z here. And if that's Z, 1 over Z, BC is now going to be what? The square root of, it's 1 plus this squared equals that. So if I have x squared minus 1, that would be what goes in there. So BC is the square root of x squared minus 1. And DC is labeled as y currently. And AC is labeled as x. And EC is not currently, oh, we could label EC as the square root of y squared plus z squared now by Pythagorean. Okay, so then what? We haven't got 7. We haven't really done anything with 7. Oh, maybe we could do this length plus this length is 7. So if I do that, I'm going to have square root of x squared minus 1 plus the square root of y squared plus z squared is equal to 7. I'm wondering if x squared minus 1 BC over DC. I'm wondering if there's some way we could do some kind of a substitution. ZX. I guess we could try What else could we do? Shoot. I remember that I found what this was, but I don't remember how I did it anymore, and I'm tired. Yeah, I wonder if I squared this. I thought at one point I had the product of these two things written. This times this. Where would I get those from? Oh, right here. Okay, so I don't know if this helps or not. I'm going to do it right now. If I cross multiply, then this is x squared minus 1 times y squared plus z squared equals xy. And then I was thinking about if you square this expression, you'll get 2xy. But it's kind of a big nasty mess from there, isn't it? I'm thinking about you square this, you'll get a copy. Like, you know what I'm saying. So you get x squared minus 1 plus y squared plus z squared plus 2 times the 2 square roots equals 49. You could drop those in here and get 2xy. But I really don't know what else you have from there. What else can we do? We have to find maybe another similar triangle. Oh, I know. We know that x plus y is 5. So if I use that, x plus y is equal to 5. In fact, we could label y as 5 minus x. I forgot about that 5 over there. Okay, so x plus y is 5. Where can I use that at? I guess I could... I don't really have an equation with just x and y in it, do we? I guess we could do, if I squared this, oh, because this is 2xy. Let's go with this. So if I square this expression, I'm going to get x squared plus 2xy plus y squared equals 25. And if I look, I have x squared plus y squared plus 2xy. Cool. We're going to bring that 1 over here to make 50. So I'm going to have z squared plus 25 equals 50. So there we go. So z squared is 25, and then z is 5. Now this might not be the best way, by the way. I have no idea. This is what I did on my test. And when I take the test as a mock conditions to kind of feel what it was like for the students. I'm not eligible, obviously, to take the test anymore for merit or anything. So z equals 5. Then what do we do? Now we have a lot of options. So you come over here, let's erase the z and put 5. And let's go back to this claim over here that we had x squared minus 1. Well, we're trying to find the area of that, right? If we could just find out what x was now. So do we know what y is? Yeah, we know what y is. So y over here, we can just replace y with 5 minus x. And I think we can solve for x now. Yeah. And our answer is going to be 1/2 times 1 times the square root of x squared minus 1. Again, write what you want so you have a plan of what you're looking for. Now I'm going to go ahead, I'm going to erase this again out of the way, and I'm going to cross multiply this. So I get 5 root x squared minus 1 equals 5 minus x. Going to square both sides right now. I'm going to get 25 times x squared minus 1. Yeah, you're going to have to solve for x. It is equal to 25 minus 10x plus x squared. Let's keep going. 25x squared minus 25. Let's move everything to this side. You'll get 24x squared plus 10x minus 50 equals 0. Divide by 2. Running out of space. 12x squared plus 5x minus 25 is 0. It's got to be something faster than this. Oh, I know. Well, I don't know, actually. You got 5 and 5. I was thinking 5 rad 2. And maybe that is the secret. Wouldn't this be the diagonal? But yeah, that would just be 5 rad 2. That doesn't really help us, though. Because that would just be, when you square 5 rad 2, you get 7 squared plus 1 squared. Okay, so I guess we're going to have to do this. I don't remember doing this, though. I remember finding it and not having to do this. But we're going to do it now. I'm going to have to erase some space over here. So I'm going to get rid of, I don't want to get rid of that just yet. Oh, I know. Oh, then this, we still don't have that. Okay. I was thinking we could get rid of all this and have just something easy to solve for x. But I don't think we can anymore. All right. Sorry, I'm getting really tired now. I'm trying to do the best I can. We're going to have to do what terrible stuff over there. So I don't want to try and factor that. So negative b is negative 5 plus or minus the square root of b squared 25 minus 4 times 12 times negative 25 times 12. Okay, cool. Not so bad. So 25, this is going to be 100, and 1225 when you square root is 35. So negative 5 plus or minus 35. It's obviously plus, so you're going to get 30 for that part, and then you're over to a, which is 24. So you have 30 over 24. You divide by 6, you get 5 over 4. That is your x value. We're going to go plug that in over here. Actually, I think I did do it this way on myself. I'm going to do it up here because I don't have space. 1/2 times the square root. 5 over 4 ends up being x, and we're squaring that x over here. Hope you can see it. We're going to get 25 over 16 minus 1, but we're going to write 16 over 16. We're going to calculate in our head and get 9 over 16. So we have 1/2 times 3/4, sorry. 1/2 times 3/4, and when you multiply that together, you finally get an answer, 3/8. Hooray, we finished that problem. And that's why it took a while the first time too, because it was like there's so many things you could do. Maybe there's a faster way. Might not be my best moment, but it helps you get the solution. I hope you enjoyed it. Catch you in the next one.